Quantitative ability, numbers. In this part of numbers, we are going to discuss in detail about the problems of LCM and HCF. Factors and multiples. If a number m divides another number n giving 0 as the remainder, then we say m is a factor of n. Also, we can say that n is a multiple of m. Now let us talk about least common multiple. The least common multiple of two or more number is the least number which is divisible by each of these numbers. Let's understand with one example. I take a number, say 18. Now what are the multiples of 18? It is 18, 36, 54, 72, 90 and so on. If I take some other number, say 30. What are the multiples of 30? It is 30, 16, 90, 120, 150 and so on. Now the least number which is divisible by both 18 and 30 is 90 here. So we can say that the LCM of 18 and 30 is 90. Now let us understand highest common factor. What is highest common factor? HCF is the largest factor of two or more given numbers. It is also called greatest common divisor. फिर से वही दो numbers लेते हैं. Let us say 18. What are the different factors of 18 which can divide 18? It is 1, 2, 3, 6, 9 and 18. For the number 30, the factors are 1, 2, 3, 5, 6, 10, 15 and 30. Now out of these factors, we know that 1 is a common factor, 2 is a common factor, 3 is a common factor, also 6 is the common factor. Now out of this common factor, which is the highest common factor, it is 6. So we can say that HCF of 18 and 30 is 6. How to find LCM and HCF? Let us say there's a question that what will be the LCM and HCF of 30 and 75. Okay, so I will write the two numbers 30 and 75 like this. So what is the common factor of 30 and 75? At first 3 is the common factor. So if I divide 30 with 3, I get 10 here, and if I divide 75 with 3, I get 25 here. Now for 10 and 25, we can take out 5 as the common factor. So if I divide 10 with 5, I get 2 here, and if I divide 25 with 5, I get 5 here. So the common factors are 3 and 5. So the highest common factor will be the product of 3 and 5, which is equal to 15. And the left out quotient, that is 2 and 5, जिसके लिए 1 से ज्यादा कोई दूसरा common factor नहीं होता. So the least common multiple will be product of 3, 5, 2 and 5 like this. So the LCM will be 150. Let's take another question. What will be LCM and HCF of 18, 24 and 60? So we will write these three numbers 18, 24 and 60 like this. At first I will divide 18 with 2, also 24 with 2 and 60 with 2, because all the three are even numbers. So I get 9, 12 and 30. So 9, 12 and 30, all the three numbers are now divisible by 3 also. So if I divide 9 with 3, I get 3 here. If I divide 12 with 3, I get 4 here. And if I divide 30 with 3, I get 10 here. Now further, there is no common factor for all the three numbers, but for 4 and 10, there is a common factor called 2. So if I divide 4 with 2, I get 2 here. And if I divide 10 with 2, I get 5 here. Right? After that, I get three numbers as 3, 2 and 5, which are prime numbers. We know that the HCF of prime numbers is 1. Now, when I want to find the HCF of these three numbers, the common factor are only 2 and 3. Because 2 is not the common factor between all the three numbers now here. So HCF is equal to product of 2 and 3, that is equal to 6. And LCM will be product of this 2, 3, 2, 3, 2, 5. So the LCM will be 360. This is one method to find LCM and HCF. Let us go with other method also. So here we will find out the LCM and HCF by the method of factorization. The same two questions I will display in front of you, where the first question is what will be the LCM and HCF of 30 and 75. So the first number 30 can be factorized as the product of 6 and 5, where 6 can be further written as 2 into 3. The second number 75 can be written as 3 into 25 first, and further it can be written as 3 into 5 square. Now when I want to find the highest common factor, I will take the lowest power of 2 and 3 here. That is the common factor. So the HCF will be 3 to the power of 1 multiplied by 5 to the power of 1, because 2 is present here but absent here in the factorization of 75. So 2 is not the common factor. Now, when I want to take the least common multiple, I will take the highest power of every prime number. So the LCM will be 2 to the power of 1 into 3 to the power of 1 into 5 square. Here it is 5 to the power of 1 and here it is 5 square. So I will take the largest power when I want to find least common multiple. So 2 into 3 into 5 square, that is equal to 150. The second question, what will be LCM and HCF of 18, 24 and 60? So how we can factorize the number 18? It can be written as 2 into 9, which can be further written as 2 into 3 square. How we can factorize the number 24? It can be written as 8 into 3, where 8 can be written as 2 cube into 3. The third number 60 can be factorized as 4 into 3 into 5, which can be written as 2 square into 3 into 5. Now when I want to find the highest common factor, obviously 2 is here, 2 is also here and 2 is also here. Okay, the common factor is 2. And second 3 is here, also available here as well as here. So the highest common factor will be 2 into 3, that is equal to 6. When I want to take the least common multiple, I will take 2 cube, the largest power of 2. I will take the largest power of 3, that is 3 square, and I will take 5 also here. That is the least common multiple, which comes out to be 360. So here we have learned how to find LCM and HCF by the method of long division, also by the method of factorization. Let us move ahead. LCM and HCF product rule. This rule says that if we take any two numbers, the product of those two numbers is equal to the product of their LCM and HCF. Let us understand this with a simple example. I take two numbers, say 9 and 12. What is LCM of 9 and 12? We know the LCM of 9 and 12 is 36. What is the highest common factor between 9 and 12? It is 3. Okay. Now, suppose if I take the product of those two numbers, 9 and 12, it will be exactly equal to the product of their LCM and HCF, that is 36 into 3. This is what the product rule says. Also, LCM is a multiple of HCF and HCF is a factor of LCM. Co-prime and relative prime. What does it mean? Two numbers are said to be co-prime or relative prime if they do not have any common factor other than 1 or their HCF is 1. For example, the number 14 and 15 do not have any common factor other than 1 and hence they are said to be co-prime. Please note that none of the two numbers may individually be prime, but still they can be said to be co-prime if their highest common factor is 1. LCM and HCF of fraction. The LCM of the fraction can be found as LCM of numerator divided by HCF of denominator, whereas the HCF of the fraction can be found as HCF of numerator divided by LCM of denominator. So let us take an example. Here it is asked, what will be LCM and HCF of 6 by 5, 9 by 25 and 21 by 50. So it will be equal to LCM of 6, 9 and 21, which is 126, divided by HCF of 5, 25 and 50, which is equal to 5. So this is the LCM of these three fractions, least common multiple of these three fractions. Similarly, if I want to find HCF, I will take HCF of 6, 9 and 21, which is 3, divided by LCM of 5, 25 and 50, which is 50. So this is the highest common factor of these three fractions. Let us try out some problems. Problem number 1. Which of the following fraction is largest? So 4 options are displayed in front of you, and out of the 4 options you need to decide the largest fraction. How to decide this? First of all, we should find out the least common multiple of denominators. The first denominator is 12. So the multiples of 12 are 12, 24, 36, 48 and so on. The second denominator, option B, is 15. So 15 के multiples है 15, 30, 45, 60 and so on. The third denominator in option C is 20, जिसके multiples है 20, 40, 60 and so on. And the fourth denominator is 30, जिसके multiples हो गए 30, 60 and so on. So the least common multiple of all the 4 denominators here is 60. Now, how to decide which fraction is largest? In option A, which is 5 by 12, I will multiply with the LCM of all 4 denominators. 5 by 12 multiplied by 60. I get 25. The second option also, 7 by 15, I will multiply with the LCM, that is 60. I get 28 as the result. The third option, option C, I will multiply with 60. I get the result as 33. And the fourth option, if I multiply with 60, I get the result as 34. Now we can very well decide which is the largest fraction. So we can say that option D is the correct answer. Problem 2. The product of two numbers is 6300. If the HCF of these numbers is 15, then the largest number is what? So let us assume the two numbers as 15x and 15y because their HCF is said to be 15 here, where x and y are co-prime or relative prime. So the highest common factor of x and y is 1. Now we have learned the product rule, which says that the product of two numbers is equal to the product of their LCM and HCF. So I can write as 15x into 15y is equal to the product of two numbers, that is 6300. So what will be x into y? Now we can say x into y is equal to 28. If we have divided 6300 with 15 and again by 15, that is 225 से अगर divide हो जाए 6300 तो we get 28 here. Now we know that x and y are co-prime. इसका मतलब x और y का highest common factor 1 रहेगा. So what can be x and what can be y to make the product as 28? The only possible option is 4 and 7 because 4 and 7 are co-prime. So the numbers will be 15 into 4 and 15 into 7. So the first number will be 60 and the second number will be 105. It is asked what is the largest number. So option D is the right answer. Problem 3. From a certain city, buses start for 4 different places every 15, 20, 25 and 30 minutes starting from 8 am. At what time for the first time after 8 am would all the buses start together again? Here we need to find the LCM of 15, 20, 25 and 30. The time after which again the buses will be together starting. So LCM can be found either by the method of long division or by the method of factorization. So here if I do long division, it will appear something like this. So the LCM of these four numbers will be 5 into 2 into 3 into 2 into 5, that is equal to 300. So the time required for the buses to start once again will be 300 minutes or so called 5 hours. So count 5 hours after 8 am. It will be 1 pm. So option D will be the correct answer. Problem 4. How many minimum number of identical square tiles are required to cover a rectangular floor of dimension 180 feet by 204 feet? So I take a rectangular floor like this, 180 by 204 और हम इसमें हॉरिजॉन्टल और वर्टिकल वे से टाइल्स अगर प्लेस करते हैं, अब कितने स्क्वायर टाइल्स लगेंगे? इट इज क्लियरली मेंशन दैट देयर शुड बी मिनिमम नंबर ऑफ आइडेंटिकल स्क्वायर टाइल्स. अगर टाइल्स का काउंट मिनिमम रखना है तो ऑब्वियसली साइज ऑफ द टाइल शुड बी एज मैक्सिमम एज पॉसिबल. दैट इज ओनली डन इफ वी टेक द हाईएस्ट कॉमन फैक्टर ऑफ 180 and 204. So the size or length of the square tile should be HCF of 180 and 204, which can be found like this. So HCF is 12. It means each tile should be of size 12 by 12. तभी tiles का count minimum आएगा. Now the question is how many such tiles are required? It's very simple. It is equal to area of the floor divided by area of each tile. So number of tiles is equal to area of floor, that is 180 into 204 divided by area of each tile. So 255 minimum tiles are required. Option B is the correct answer. Problem number 5. There are some chocolates with the teacher. If he distribute them equally among 10, 16 or 20 children, he is left with one chocolate in each case. If he distribute the chocolate equally among 23 children, he would not have any chocolate left. How many chocolate the teacher has? Well, the number of chocolates with the teacher should be equal to LCM of 10, 16 and 20. into k plus 1 because it is distributed equally among 10, 16 or 20 children. One chocolate is left. Hence, I am doing plus 1 here. I am taking LCM of 10, 16 and 20 plus 1. Now, what is this k? I will tell you. So, सबसे पहले 10, 16 और 20 का अगर हम LCM निकाले तो that comes out to be 80. So, it is 80k plus 1. Now, the second case that is told here that if it is distributed with among 23 children, no chocolate is left. So, what should be k here? If I take k is equal to 1, suppose the number of chocolates will be 81 and 81 is not divisible by 23 because अगर वही 81 चॉकलेट 23 से डिवाइड करे तो रिमाइंडर अपने को 0 नहीं मिलता और यहां क्लियर बोला है he would not have left any chocolate. So k cannot be 1. Suppose if I take k is equal to 2, the number of chocolate count will be 80 into 2, that is 160 plus 1, that is 161. So 161, if we divide with 23, we get 0 as a remainder. So the teacher must be having 161 chocolates as 161 follows both the case. अगर हम 10, 16 और 20 से डिवाइड करें तो रिमाइंडर 1 मिलता है और 161 को अगर 23 से डिवाइड करें तो रिमाइंडर 0 मिलता है. So the correct answer is option D. And from here we will understand two important models of LCM and two important models of HCF which is based on such type of questions. LCM model 1. I take a number n and I divide this number n with a, b and c as well. Every time I am getting the same remainder r, whether I divide n with a or b or c. How the number n can be found out? It can be found out by taking LCM of a, b and c plus adding the remainder r. Let us understand this with a simple example. Let us take a number n which is divided by 4 or 5, leaves the remainder of 2 in each case. Then n can be found out as. So n अगर ऐसा नंबर लेता हूं मैं और जिसको 4 से डिवाइड करो चाहे 5 से डिवाइड करो, दोनों बार आपको रिमाइंडर 2 मिल रहा है. So n कैसे निकाल सकते हैं? It will be equal to LCM of 4 and 5 plus 2, which is equal to 22. The smallest such number is 22. So 22 को चाहे आप 4 से डिवाइड करो चाहे 5 से डिवाइड करो, आपको रिमाइंडर 2 ही मिलना है. Another possible value of n can be 42, 62, 82, 102 and so on, which can be found out as like this. It will be LCM of 4 and 5 into k plus 2. यहाँ पर अगर हम k जोड़ दे तो अपने को ऐसे मल्टीपल आंसर्स मिल सकते हैं जैसे 42, 62, 82, 102 and so on. Okay. So in this model, if the remainder is same, we take LCM of the divisors, that is 4 and 5, and we add remainder to it, we get the required number. LCM model 2. In this particular model, again I take the number n and I divide the number n with a, b or c, but here the remainders are not same. This is the basic difference between the previous model and this model. In the previous model the remainder were same and here the remainders obtained are different. But in this case there is a common difference between divisor and remainder. Remainder भले ही same ना हो लेकिन divisor और remainder में difference same है. That is a minus p is same as b minus q is same as c minus r. That is called common difference. How the number n can be calculated? It will be equal to LCM of ABC minus this common difference. Let us understand with an example here. If we take a number n and if I divide it by suppose 4, I get remainder as 1. Or when I divide it by 5, I get the remainder as 2. So what we see, the remainders are different, 1 and 2. But there is a common difference between these remainders. So the number n can be calculated as LCM of 4 and 5 minus this common difference. That is, the common difference is 3 here. 4 minus 1 is 3. Even 5 minus 2 is 3. So LCM of 4 and 5 is 20 minus the common difference 3. The resulting number is 17. So 17 को देखो आप 4 से डिवाइड करो तो भी आपको रिमाइंडर 1 मिलेगा और 17 को आप 5 से डिवाइड करो तो रिमाइंडर 2 मिलेगा. Okay. Other possible values of n are 37, 57, 77, 97, 117 and so on, which can be calculated as like this. So यहाँ पर सिर्फ आपको k जोड़ना है, LCM of 4 and 5 into k minus the common difference. If k is 1, the number is 17. If k is 2, the number is 37. If k is 3, the number is 77, and so on. Now let us try out some questions on LCM models 1 and 2. Problem number 6. Find the smallest 3-digit number which when divided by 15 or 25 leaves a remainder of 5 in each case. Here the remainder is same. So obviously this is LCM model 1 question. तो इसको कैसे solve कर सकते हैं? We need to take the LCM of 15 and 25 and we need to add the remainder to it. So LCM of 15 and 25 we know it is equal to 75 into k plus 1. अब यहाँ पर पूछा है find the smallest 3-digit number. If I take k is equal to 1, obviously it will be 75 plus 5, that is 80, which is a 2-digit number. But यहाँ पूछा है smallest 3-digit number. For that I should take k is equal to 2. If we take k is equal to 2, the smallest 3-digit number that we will get here is 155. Option C is the right answer. Problem number 7. Find the largest 3-digit number which when reduced by 7 becomes divisible by 8, 14 and 20. Now this is a model 1 only. The required number will be obviously LCM of 8, 14 and 20 plus 7, because उस नंबर को जब आप 7 से रिड्यूस करते हो तब जाके वो 8, 14 और 20 से डिविजिबल होता है. So the required number will be LCM of these 3 plus 7, ताकि 7 से कम करोगे तो डिविजिबल हो जाए. Okay, so what is the LCM of 8, 14 and 20? We can calculate it like this. 2 into 2 into 2 into 7 into 5. So that comes out to be 280. So it can be written as 280 into k plus 7. Now in this question it is asked largest 3-digit number. So we need to appropriately select here the value of k. So if we take k is equal to 3, we get the largest 3-digit number, which comes out to be 847. So option A is a right answer. Problem 8. There are some fruits on the tree. If the farmer plucks 21 fruits every day, then 4 fruits are left on the tree at the end. If he plucks 24 fruits every day, then 7 fruits are left on the tree at the end. Find the minimum possible number of fruits on the tree. Let us assume the minimum possible number of fruits on the tree as n. So if we divide the number n with 21, then 4 fruits are left because he is plucking 21 fruits every day. So we are dividing n with 21. So 4 is the remainder left. And if he plucks 24 fruits every day, that is, if we divide n with 24, 7 is the remainder that is left. So here the remainders are different, but still there is a common difference between divisor and remainder. If I take 21 minus 4 and if I take 24 minus 7, the common difference is 17. So this is LCM model 2. The remainders are different, but there is a common difference between divisor and remainder. So here we can find out n as LCM of 21 and 24 into k minus the common difference. So what is the LCM of 21 and 24? It is 168. So 168k minus 17. As we want to find the minimum possible number of fruits on the tree, I will take k is equal to 1. So taking k equal to 1, it is 168 minus 17, which is equal to 151 fruits. So option B is a right answer. So such type of questions are asked in competitive exams. Let's proceed to the next question. To go ahead with the further problems, first of all, let us understand HCF models. HCF model number 1. So if I take 3 different numbers, say A, B and C, and all the 3 numbers I divide with one common number, that is n, like this. So I get 3 different remainders as P, Q and R. How to find largest such number n? This can be found like this. सबसे पहले अगर आप देखोगे पहला नंबर A, जिसको अगर हम n से डिवाइड करें तो रिमाइंडर P मिलता है. अगर ये P ही मैं A में से माइनस कर दूं तो डेफिनेटली बचा हुआ नंबर a माइनस p n से डिवाइड हो जाएगा. सिमिलरली अगर मैं q b में से माइनस करूं तो बचा हुआ नंबर b माइनस q n से डिवाइड हो जाएगा. In a similar way, if I subtract r from c, the leftover number c minus r will be divisible by n. So the largest such number n can be found as highest common factor of a minus p, b minus q and c minus r. Let us understand by example. Let us take the numbers 17, 23 and 34 when divided by a number n which are leaving a remainder as 2, 3 and 4. तो अगर 17 में से मैं 2 माइनस कर दूं तो वो n से डिवाइड हो जाएगा. सिमिलरली 23 में से भी अगर 3 में माइनस करूं तो वो n से डिवाइड होगा और 34 में से भी मैं 4 माइनस करूं तो वो n से डिवाइड हो जाएगा. सो n will be equal to HCF of 17 minus 2, 23 minus 3 and 34 minus 4, which is equal to HCF of 15, 20 and 30, that is equal to 5. So if I divide 17 with 5, obviously the remainder will be 2. If I divide 23 with 5, the remainder will be 3. And if I divide 34 with 5, the remainder will be 4. So 5 is that number. This is what HCF model 1 says. HCF model 2. In this model of HCF also, we are taking the same three numbers ABC and we are dividing by the number n. But here we are getting the same reminders. How we can determine the largest possible value of n? This can be found like this. We have to take the difference of first two numbers a and b and we have to take the difference of next two numbers b and c. और ये दो difference का HCF लेना पड़ेगा. Let us take the numbers 14, 26 and 62 which when divided by the number n leaves the same remainder in each case as follows. So here n can be calculated as difference of 26 and 14 and difference of 62 and 26, which is equal to HCF of 12 and 36, which is equal to 12. So if I divide 14 with 12, I get the remainder as 2. Even if I divide 24 with 12, I get the same remainder 2. And if I divide 62 with 12, I get the same remainder 2. देखो ये तीनों नंबर को अगर मैं 2 से भी डिवाइड करूं तो भी मुझे वही रिमाइंडर मिलेगा, या 4 से भी डिवाइड करूं तो भी वही रिमाइंडर मिलेगा. बट वी नीड टू फाइंड द लार्जेस्ट सच नंबर एंड दैट लार्जेस्ट सच नंबर कैन बी फाउंड बाय एप्लीकेशन ऑफ दिस मॉडल which comes out to be 12. Problem 9. Find the largest number which divides 49, 74 and 115, leaving the remainder as 1, 2 and 3 respectively. So as the remainders are different, it is a HCF model 1 question. So when I divide 49 with n, remainder is 1. If I divide 74 with n, remainder is 2. And if I divide 115 with n, the remainder is 3. So what I will do, I will subtract 1 from 49, 2 from 74 and 3 from 115. The leftover number will be definitely divisible by n and the largest possible value of n can be found by taking HCF of these three numbers, that is 48, 72 and 112, which comes out to be 4 into 2, that is equal to 8. Problem 10. Find the greatest number that will divide 43, 95 and 187 so as to leave the same remainder in each case. So here if I divide 43 with n or even 95 with n or 187 with n, the remainder is same. It means this is HCF model 2. So n can be found with the largest possible value as HCF of 95 and 43 difference and 187 and 95 difference. So we need to find the HCF of 52 and 92, which comes out to be 4. So 4 is such largest number which divides 43, 95 or 187, giving you same remainder in each case. Let us see. If I divide 43 with 4, obviously the remainder will be 3. If I divide the next number 95 with 4, again the remainder will be 3. If I divide 187 with 4, again the remainder will be 3. So 4 is that largest possible number which gives you same remainder through HCF model number 2. So option A is the correct answer. So here we have learned the topic of LCM and HCF in detail. Thank you for watching this video.